A particle with a mass of 2 kilograms begins at x equals 1 with an initial velocity of 0 meters per second. Using its potential energy curve below, find the speed of the particle at x equals 16 and the force that it is experiencing at x equals 4. Let's begin our work for this Jigglypuff-shaped curve. Let's start here at x equals 1, where the particle's energy corresponds with about 9.5 joules with zero kinetic energy as seen on the curve with respect to the y-axis, which is denoting the amount of potential energy. Because we have no kinetic energy at this point, our potential energy is always 9.5 here, and the total energy of our system is also 9.5 for this entire situation. Now, if we establish what we want to know, we're looking for the speed at which the particle is traveling at x equals 16 and the force it experiences at x equals 4. Let's look for speed first. The first thing we want to do is determine how much kinetic energy the particle has at its position because it has moved so much from its starting point. We do this by subtracting the corresponding potential energy from the potential energy we began with. Our beginning potential energy is equal to our total energy, which is 9.5 joules, and our final potential energy in this case would be about 2.5 joules. So 9.5 minus 2.5 is 7 joules, which is equal to the amount of kinetic energy we have at this position. Remember that the mass of our particle is 2 kilograms, which will be important in calculating speed. We set our kinetic energy equal to 1/2 mv squared, which is the equation for kinetic energy by definition. We are looking to isolate v by multiplying both sides by 2, dividing by our mass, which is also 2, and squaring both sides to find that v equals 2.65 meters per second. Now we find the force. As we know, the negative slope of a potential energy curve equals force, which is the negative change in potential energy over the change in position. We also know that slope equals rise, change in y, over run, change in x. So when we find the slope here, we take the change in y, which equals the change in potential energy, following the same process we used previously. We take 8.2 minus 9.5, which equals negative 1.3, over 4 minus 1, which equals 3 meters to yield negative 0.433 newtons. Taking the negative of this, we get positive 0.433 newtons, which is the force our particle experiences at x equals 4.